Hey everyone, geophysicist Stefan Burns here. A significant Earth shift started just over the past couple weeks. And when I mean significant, I mean we really don't know how much the Earth is going to change from this. There were two nova explosions that lit up the sky. One was on June 12th, the other on June 22nd, I believe. We'll look at the data. Maybe it's June 26th, it might have been June 26th. Either way, back to back, either nova or supernova explosions. And then we've been seeing a lot of interesting things happen immediately following that. We've had some dramatic flooding all across the United States, and not just normal flooding, but like flash flooding. A lot of these floods actually aren't even being reported. There's so many of them. So massive amounts of rainfall in the United States. We're having volcanoes wake up that have been dormant. For example, Mount Rainier has had the biggest earthquake swarm in a long time. The earthquake swarm that it had in 2009 was about 120 earthquakes. Now it's had about 400 in the past month, 350 plus in just the past 2 days. We have Mount Ruapehu volcano in New Zealand. It had an earthquake swarm. We've had earthquakes pop off. Lewotobi, Laki-Laki in Indonesia has been erupting basically almost continuously now, sending up some of the most spectacular ash plumes in the sky. We've had some eruptions in Japan near these earthquake swarms. The Tohoku Island earthquake swarm is still happening at this moment in time. There was a burst of earthquake activity also to the east of that, and this earthquake this volcano that popped off is right basically in between the two. So it seems that there was some sort of influx of energy, and these two back-to-back nova / supernova explosions would be a good candidate for that. We have massive temperature anomalies in and around Antarctica at this moment in time. Some of these temperatures being very, very high, others being very, very cold, basically creating some sort of polarity to them. This would kind of strengthen the argument for these nova eruptions or explosions that have some effect on Earth, because they were most visible from the southern hemisphere. So that energy is coming up to the southern hemisphere. And Antarctica, of course, is the bottom of the southern hemisphere. So we have that, and then we also have our sun giving us signs like it does with this coronal hole here. I believe it's the 12th rotation. We've been tracking this since October. I've talked about it a lot. I think it's number 12. You start to lose track of these things. Kilauea popped off recently, episode 28. That was a big lava fountain event. But this coronal hole here is about to really connect to the Earth with its high-speed stream and therefore its magnetic field, and that's expected to give us a geomagnetic storm. We're already actually seeing geomagnetic volatility go up right now at this moment in time as the higher density region in front of the higher velocity, lower density, high-speed stream that sweeps by. So this, though, to me looks like a dragon. I see a dragon with this. I can also see, for example, like a phoenix or pterodactyl, right? It just looks like some sort of winged creature. I think that's interesting, but it really looks like a dragon to me, and that would be very fitting for the times. It seems that there are profound changes occurring on our planet, and so my intuition is telling me that something big is like coming. I don't know to what scale. I don't think it's going to be the end of the world or anything, but things have, we've had a lot of energy come in from the sun due to solar maximum. Solar activity overall is down in terms of like solar flares, in terms of the light flux being emitted. We're starting to hit the rounded part of that maximum where we start to go to the descending phase. So we're like on the tail end of maximum unless there's a second spurt back up, which we may get that. I think we'll probably get a second little spurt of activity later this year, but we'll just have to wait and see. So we've had all this energy come into the Earth from the sun. Now we have these two nova / supernovas that have pumped energy into the Earth. And we're seeing all of a sudden these big climatic shifts, salinity reversals in around Antarctica with the ocean there. So an SMOC salinity reversal also indicates a circulation reversal, or at least disruptions and changes to circulation. And this all speaks to some of the deeper geologic factors that are at play. For example, the proto-Earth, long time ago, billions of years ago, the oceans were 2-3 times bigger than they are now. They went over the peak of Everest. And so doing some research there, I think our Earth is much more dynamic than we think it is. And if certain conditions are met, perhaps we could get some pretty serious events to unfold. So we're just in this video going to go through everything as best as possible. I don't have all the answers. I don't have all the data. I'm one man on a mission to understand what's happening on the planet energetically. If you'd like to stay a part of that exploration, that journey, and to learn about all this stuff as you go, earth science, astronomy, astrology, metaphysics, and more, then please subscribe to the channel. If you're jumping into the live stream right now, hello, I'm your host, Stefan Burns. And yeah, so this coronal hole is already starting to give us a bit of an impact, but it's really this right there. This section is the part that cuts across the solar equator. And when that sweeps by the Earth, that's when we're expected to have this geomagnetic storm begin, what I also sometimes call a geostorm. And so G1 to G2 conditions can be expected from that, perhaps G3, but probably more like G2 conditions, which would be a KP index of 6. For those that are new, the scale rating goes to 5. So you have G1, G2, G3, G4, G5. G5 is severe. The last G5 storm, big true G5 storm, was May 10th to the 12th of 2024. We've had some G4 storms since then. Those are severe. G5 is extreme, and G2 is what they call moderate, because a G1 is like mild, then moderate, then strong for a G3. So this is like the cherry on top of everything. We already have all this instability with the Earth, the energies, and then we have this coronal hole high-speed stream coming in for impact number 12. I believe it's number 12. Impact 12, and then, well, boom shakalaka. So let's just look at the globe and just kind of zoom around here for a bit, because there's a lot happening, and I'll do my best to kind of cover it all. But yeah, there's just a tremendous amount happening. And by the way, we will do a question and answer at the end of the video. So if you'd like to ask a question now, just attach it to a super thanks. Those will get priority. I can pull those up at any time. And then you can also type at Stefan Burns during the question and answer, and I will hopefully answer your question. But there's usually so many, it's a little bit of luck of the draw. So you'll definitely get your question answered if you attach it to a super thanks. And so here we have our Earth, and let's actually start, well, let's go to Mount Rainier, because this is the big kind of shocker. Just starting on June 8th, we had a bunch of earthquakes start up, basically like 100 plus earthquakes, then went to 200 plus. Now it's at 350 plus earthquakes. So the normal rate of earthquakes at Mount Rainier is about 9 per month. And right now it's significantly more than that, a 44 times increase, and actually going up. Maybe it's about 50 times increase right now. The 44 times is from what I calculated last night. I almost did a live stream last night on this, but it's too late. And so in 2009, there were 120 earthquakes. This did not result in an eruption. The last big eruption from Mount Rainier is 1894. So it's been a while, but this is a massive, massive volcano. As you can see, one of the largest from space for the United States. You see Shasta down there, right? This little guy is Shasta. But if you go up, Mount Rainier is definitely the big baddie on the West Coast, and visible from all over the place. So it is really a significant, huge, huge volcano. And this earthquake swarm does seem to be slowing down, but these things often come in pulses as well. So you have to keep that in mind, because it could just be, okay, we've had the first pulse of activity, we haven't had the rest yet. Here we see Mount Rainier, and just look at that. It's a big volcano. So imagine that thing blowing its top. because the geology of Mount Rainier is that there's actually some older proto-volcanoes underneath, and then the newest part of this stratovolcano is built on top of that. So there's successive layers, and it's been active for millions of years. So this is a zone that has had big eruptions and will have big eruptions in the future. So right now, officials are not warned. They have worried. They have not increased the alert level for Mount Rainier, even though there have been about 400 earthquakes in the past month. And that's because they're not seeing any signs of deformation or like active off-gassing with their various like webcams and GNSS data feeds, you know, these probes that can measure the change. They're not seeing that. We're only seeing earthquake swarms, and the USGS officials are saying that this is due to just basically the movement of fluids along pre-existing faults and fracture zones. And the highest magnitude earthquakes for this have both been magnitude 2.3. So those are quite weak. But that is still 400 earthquakes effectively in the past month. Let's pull up that data really quick. I have it right here. Here we see our earthquake map for Mount Rainier, and we can zoom in and see all the earthquakes in the past 2 days in orange, and the past 2 weeks in yellow. And so some of those are just outside that 48-hour range. And then you'll notice that we don't really see any in red, though maybe I should refresh this. So let's just refresh this really quick. And I don't think we've had any earthquakes in the past 2 hours. So it has been slowing down, but you'll get a sense of what I'm talking about with this potential pulse type activity if we go here. I'm going to draw a cross section through this, okay? So we simply just put this there, expand that out, and then we're going to look at the cumulative number and plot that. Look at that. This goes back to about June 17th or so. So it's not even showing a full month here. And we were about 50, no, not even 50, about 25 right when the swarm started. So we already actually had a little bit of an elevation because, again, the average is 9 per month. So we were starting to already actually have a little bit of an activation there. And then we went up about 400 earthquakes now, because this is probably just under 425, maybe it's 420 or so. So we've had nearly 400 earthquakes in this swarm just in the past about 72 hours, less than 72 hours. And so is it just going to be this, and then is it going to flatten off, or is this going to be the first of many pulses or another pulse? Like, these are all unknown. So if you live in the area, you should definitely be aware of this. I wouldn't be freaked out or anything, but you should definitely be aware of it, especially when you consider if there is an eruption on Mount Rainier. Not saying there's going to be, but there is an eruption on Mount Rainier, then the effects could be quite significant. So here we have our data. This is from USGS showing this earthquake swarm in the orange set on top of the historic earthquakes going from 2020. So you see that the normal earthquake activity is quite a bit wider, but these are localized right there and pretty close to like the main summit caldera. So not that far down. We'll look at some other earthquake data for Mount Ruapehu in New Zealand. That's quite a bit different, but also they had that swarm. And then we see here the hazard zone for if there is a big eruption, the lahars. If there's any sort of pyroclastic flows that come out, which is what you get often from like a big volcanic eruption, you expect probably some pyroclastic flows. It's going to melt all that ice and snow and create lahars. And they estimate that these lahars could run all the way out to the Puget Sound. So that could be very devastating for anyone living in these river valleys or nearby. This is the actual slope of the mountain. All that would be affected by the pyroclastic flows. And so this is not something to just say, oh, nothing's going to happen. Like, we hope nothing's going to happen. It's the most likely scenario probably. But in the context of the solar activity, solar maximum, and this coronal hole adding a little spike on top of all this energy loading that we've had, and in the context of these nova eruptions, well, you just have to be, I think, a little bit more careful and take things just, yeah, like, just be more careful and expect the unexpected. We've just had Uranus shift into Gemini, the sign of Gemini. That's a big release of Earth energy over the next 12 months or so. And we have Saturn and Neptune about to go conjunct nearly 13 arc minutes apart in just a couple days. And that's a big initiatory energy. We'll talk about that. But let's look and talk a little bit more about these temperature anomalies that we're seeing, because this is kind of why I'm thinking that there's more to this story than meets the eye. So here we have our temperature anomaly map. This is the temperature at 2 meters above the surface, and this is set for Antarctica. All right, so if I actually scroll down here, and you'll notice that they're most extreme around Antarctica. So of course there's temperature anomalies up here, but look here, you get massive positive temperature anomalies, right? Going up significantly. This is like standard deviation jumps, like 1, 2, 3. And then you also have massive negative temperature anomalies. If it was white, everything would be around normal, but it's not. So we're seeing this big differential buildup where you have strong, really high temperature and then really low temperature right next to each other. And that's quite bizarre. So that is very weird. Scroll up again to our more qualitative look right there. It was actually stronger a couple days ago. It has diminished slightly, but a couple days ago it was even getting up into this like white range. So this is in Celsius. So you're talking about 20, 25, even like 28 degrees Celsius or over normal or under normal, because these, and actually we still have some of those values right there. If you see that, that's starting to turn into that like whitish purple. So huge temperature anomalies in Antarctica. And if you consider these nova explosions, then that is a potential explanation for what this is, because we've seen across time that these nova eruptions seem to correspond with climatic shifts. And so if that's the case, this could be a very big deal. And I have a podcast coming out very soon with Max Raymond. I'll introduce you guys to him in the podcast. We talk about this more, and we provide that historic context. But if you're having these novas or supernovas from the southern hemisphere, that energy is going to hit the southern hemisphere more so than the northern hemisphere. You can have non-homogeneous climatic shifts potentially from these influxes of energy from interstellar sources. That's the idea. Here we see the light curve for the first one. It really popped off June 12th and 13th. We see all of a sudden shoot up like this. This is V462 Lupi, and it has basically maintained itself. This is just a couple days out of date now. And then if we look at the other one for V572 Velorum, this also was a nova eruption. It started, right there, June 25th, 26th. We see it spike up, actually reached a higher visual magnitude, is more brilliant and lit up in the sky, and it's now settled out around a 6. So they're now both naked eye visible, and they were both very visible when they reached their peak. V462 getting all the way up to about 5, and Velorum getting to, again, like 4.8 or so. So these are really significant explosions. Max thinks that they're supernovas. There's the possibility that they're novas. Like, how do we know? That's kind of a good question. It's not like we know exactly what's happened, whether it's been a nova or a supernova, because a supernova, it depends also on the distance. So if it's further away, the light reaching us is going to be a little dimmer. So you could mistake it for a nova. We're going to have to really like punch in on these things and study the emissions and things of that nature to determine. So it could be supernova explosions that have occurred in our nearby zone. It could be nova explosions, or it could be one supernova, one nova. They're both possible. But this is seemingly causing some changes here on Earth. At least it's a strong candidate for these extreme temperature anomalies in Antarctica. And then we are seeing anomaly. What was that? That was a weird one. And we're also seeing anomalies across the rest of the globe too. Greenland's an anomaly. Some people are also talking about these polar vortices, the jet streams, how they're kind of breaking up and fracturing. No longer is this just nice in one solid vortex like this. I can't comment too much on that. I'm not the biggest expert on jet streams and solar vortices, but it is interesting. Well, let's actually go straight into our real-time solar wind so we can see this impact from the sun. There's a lot to cover today. It's like a little difficult to put it all into one comprehensive package because there's so much happening. So that's really where all the work that I've done with this channel pays off, because I've researched into all these things quite extensively. I'm not the ultimate expert, but I'm doing my best. So here we have a real-time solar wind, which allows us to track what's happening with the solar wind. We measure this 1% of the distance from the Earth to the sun. So it gives us a heads up of about an hour. You'll notice our solar wind effectively went to like 0 here. 1 and 1, 1 and 0. Like it got really weak effectively. And then we see our geomagnetic volatility here measured by the KP index go down, down, down. And we had very quiet conditions. Look at that, less than 1, just less than 12, about 12 hours ago. Each one of these blocks is 3 hours, so that's 15 hours ago. We were under a KP value of 1. Our solar wind velocity was incredibly low, reaching down to under 350 kilometers per second. Our density was about average, a little lower than average, I would say. And then our temperature was also nothing extraordinary. We just had a section boundary crossing right there. You can see that our phi angle shifted. So we went from a solar wind magnetic field that's pointing towards the sun, and now we are shifted so it's pointing away from the sun. It's now in the positive sector, which is that polarity of the coronal hole. It's a positive polarity coronal hole, and you see that all of a sudden our solar wind strength has dramatically increased. Now it's at 12, average is 5 nanotesla. It even reached up to about 13 or so at the peak, and we had a strong southward component. So this is just coming in basically at this moment in time. And again, if we go back here, we will see that this has not gone geoeffective yet. And so it's the coronal holes that really are linked to earthquakes. There's quite a bit of research on that. The jury is not out yet. The jury's still out, but in general, there's a strong connection between these coronal holes, their high-speed stream impacts, and significant effects on Earth. Because there's research connecting them to earthquakes, specifically the biggest earthquakes like megaquakes. You look through the records that we do have, going back about 70 years, 50, 70 years, every single high-magnitude earthquake had a significant coronal hole either center or in the geoeffective position right there. Every single one. Just look through the records if you don't believe me. And for some of the naysayers, do the work, look through it. Then, but our records are super limited too. Like on a geologic scale, that's nothing. So it's really difficult to confirm or deny this stuff. But there's also good research connecting these coronal hole high-speed stream impacts to tornado outbreaks in the United States, in Australia, just anywhere that can get tornadoes. That research is also there, showing a larger connection between the sun and the Earth energetically. And so you get this on top of those energy influxes from the novas. We undoubtedly had energy influx from the nova or supernova eruptions, explosions. Undoubtedly, because we see all of a sudden the light output go up 4 million times for a V462 Lupi, for example. So we see more light. We're getting gamma rays from that. We're getting all the different frequencies. Then there's going to be relativistic ions that are slower but close to the speed of light. They're going to flood in afterwards. The question is, how close are we to that beam of the explosion? We could get hit something bigger even, actually. If there's like plasma that's very fast, that's traveling behind it. These are all possibilities, but we know that we got more energy than we would have otherwise. Today's the full moon. Last night was beautiful full moon. So we're still in that full moon period. That's bringing more energy into the Earth. The tidal forces are stronger right now. We have the solar wind increasing strength. The coronal hole high-speed stream is about to go geoeffective. That part right there, transequatorial, likely to give us a G1, G2 storm. We have these earthquake swarms that are still active. The one in Japan just recently rattled off some new earthquakes. We have Uranus just having shifted into the sign of Gemini, which is this big Earth release of energy. And there's a time window that this will kind of play out in. And then we have Saturn and Neptune about to go conjunct. And maybe that is what I should just quickly bring up for you now. And then we have all these other volcanoes and things that are awake and active at this moment in time. So I don't know what this is going to lead to. I just have a feeling, I just have a deep feeling that something is coming. And how these energies are going to express, I don't know. Is it going to be geologically? Is it actually going to be societally? Right? I just don't know. But I feel something's coming, which is why I'm reporting on this and showing you as much as I can with all the skills and tools that I have. So look at how close a conjunct these two are right now. This is July 11th. We have Saturn right there, and there is Neptune. This is an application called Solar System Scope. And if we go forward to the 13th of July, that is where they are nearly conjunct, just 13 arc minutes apart from each other. And then if I zoom forward just a bit, we see that Saturn retrogrades faster. So we lose that conjunction. And if we go actually to the middle of September, we have some significant planetary geometry. So right here, for example, we have Venus conjunct Jupiter from heliocentric standpoint. If I even go back a little bit right there about September 12th, that's a nice alignment between Venus and Jupiter. And then we have a Mercury Cazimi. Do you see that? Here we have a superior conjunction with Mercury right about here or so. It's a little difficult to line it up, but let's zoom out on top and get a sense of that. Right about there on the 12th of September, we have a Mercury Cazimi around that zone. These seem to really affect space weather because Mercury is very close to the sun, and the electric currents from the sun, these Birkeland currents, the research indicates that they actually connect down in the core and the mantle of Mercury because it doesn't have an ionosphere that has an ability to host an electric charge and basically connect the circuit together like you can get with Venus. Venus has these electric current filaments that spread all across the atmosphere all over. So it's very electrically active. It doesn't have a magnetic field like we do, but the sun and the solar wind is able to connect directly to Venus's very active ionosphere and complete the electric circuit that way. For Mercury, it has to go down probably to the mantle or the core itself. I think it's just basically the core. You know, we don't exactly know the composition like the interior of Mercury, but it's close, and we see significant solar flare activity around these Mercury Cazimis. So we do have some significant geometry coming up on September, because if I flip it around, you'll also see immediately after that, then we get this heliocentric lineup between the Sun, the Earth, Saturn, and Neptune. They are not as close together as they were for us geocentrically, basically right now, but they're pretty darn close. And you'll notice that there's also a new moon right around that time. See our moon right there? That's our moon. And we go back, see how we get this new moon sliding into that configuration. So big gravitational alignment there as well. So if I go back though, that's just a little bit of a heads up for everyone because I like to provide those long range forecasts. And that's in between eclipses. Both we have the lunar and the solar eclipse in September. And that's also right around equinox when you have a stronger connection from the solar wind to the Earth's energy system, the magnetic field, and more. And equinox itself is a powerful energetic portal, you could say. So that is why September is looking really intense for something. But right now, if we go back to basically today, we see here that Saturn and Neptune nearly conjunct from a geocentric perspective. This is in the very beginning degrees of Aries in Western tropical astrology, the sign of Aries, not the constellation. You see the constellation right behind. That's actually not Aries, that's Pisces, right? So constellation-wise, it's in Pisces. But sign-wise, Western Tropical, which tracks the local reference frame of the solar system, that's in Aries. And that is a very big initiation energy. So that is very significant. That's also at play right now at this moment in time. Let us talk about this swarm moving away from Mount Rainier to New Zealand. I want to bring attention to Ruapehu, which also had an earthquake swarm. We see that this is a pretty big volcano right there. And this on the North Island. And we also had this magnitude 6.3 there the day that Uranus shifted into Gemini, you know, the sign, on 7/7 portal. So a lot happening. So that's Ruapehu. And we have the earthquake data for Ruapehu provided by Volcano Discovery. Here we can see all these earthquakes, and you see that they're on like the eastern flank of the volcano. Quite a lot. It's like 100 plus earthquakes here. And if we scroll down, we can see our quake magnitude and depth over time. This is the past 30 days. So this is that swarm right there. And basically we've had normal earthquake activity since, but look at how these are at a lower down. So they're deeper below the surface, and they basically created an upward channel of fracturing and faulting. If we go back to a year, you'll see that that's the only spike of earthquakes going down at depth. So that's indicating some sort of movement and flow of energy from deeper down, closer up to the surface, whereas most of these earthquakes are just popping off in this 10 to 15 kilometers down range, and then also around 5 kilometers. But that is showing something coming up closer to the volcano from deeper, and that is very interesting. We can also see our number of quakes across time for Ruapehu, and we see that it spiked in 2015 and 2016. And so there were 261 and 258 earthquakes greater than magnitude 2. For example, with Rainier, it's only been 2 magnitude 2.3s and a magnitude 2. So this puts this into context, but we see that it was a lot quieter back here, and it's been really picking up. This could be due to the fact that we have better seismic data now, collection methods. That's probably definitely part of it. But this swarm, not the biggest swarm, but certainly something to pay attention to. Here we see it zoomed in 7 days, really coming in from depth. So that was active. And then we also had on the 3rd of July, we had Mount Shinmoedake basically have a very large eruption in Japan. So here we see that, and that was a significant eruption. And what's interesting about that is the location of it. So it was a very tall ash cloud. It did not reach up to the stratosphere, but it did go up like I think 10,000 meters, something like that. Big eruption. So nothing to sneeze at, though it was a volcanic sneeze. Here we see the location of it. So here's Mount Shinmoedake. I hope I'm pronouncing that correctly. You'll see it's an active volcano. Look at all these other like calderas nearby. There's one, right? Here's a whole bunch. The whole area is littered with these calderas, and basically those are all past eruptions. And so this whole zone is quite active, but we zoom out, okay? Zoom, 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 zoom. Well, here's the Takara swarm. That's 1,000 plus earthquakes. It's probably close to like 1,500 now. And then here we had an earthquake swarm that started on the 9th. It wasn't a big one, but magnitude 5.3 and some other high magnitude like low 5s and high 4s, which are equivalent to what's been happening here. So that's interesting. And then I looked in between the two, just curiosity, and you notice these underwater volcanoes as well. So don't forget that most of the volcanoes on the Earth are actually under the water and basically unexplored and not monitored, because if you don't have a seismic network right in that zone, you're not going to capture those magnitude 1s, those magnitude 2s, those magnitude 3s. So there could be a lot happening out here. I don't know if we have a seismic network there. I don't think we probably do. We probably have, the Japanese probably set up their seismic networks mostly on the islands and the land. I doubt that they've dropped one in here, maybe. We'll check the Japanese meteorological earthquake map. If it's going to be there, it's going to be on there. But just what a weird geologic formation here. You have this massive subduction zone trough, and then you get this larger trench type feature. And right in the middle of it, you get these volcanoes. You can even, with the limited bathymetry data we have, look at the caldera there, right? So there's just a lot of weird stuff happening in and around Japan right now. Here we have our map of earthquakes from the Japanese Meteorological Agency. As you can see, they're not tracking any earthquakes in there. So either none have occurred, or more likely they just don't have the seismic stations to pick up those smaller magnitude earthquakes. I bet that's almost certainly the case, having worked in this industry and sold seismographs to these sort of groups. And deploying like underwater seismographs are quite difficult to deploy, especially at depth. You have to get that signal up to the surface and then beam it to a station. So it's really a quite intensive endeavor, costs a lot of money, and therefore typically they only put down these submarine seismometers when there's something happening. Like they deploy them in Greece when we had that seismic swarm around Santorini. They put a whole bunch of them around the area basically as soon as they could. But it's not an easy thing to do. But if we go here again, this is our swarm. It's a little better to see zoomed out because otherwise it forms this grid pattern, which is just based off of how like the data is put into this map. That's what we think. But if we go here, so here's our little, the Japanese always do weird things like this on their websites. I love it. It's great. They're the best. I really need to get to Japan. It sounds like a wonderful place to visit. So if we go here we see them, and yeah, there's been more earthquakes. We see adjacent Sea of Takara Islands. That is our swarm, and we see that it started back up again on the 11th. Look at how many there are with that labeling. We see it kind of died out a bit, but if we go back, it's been going on now for weeks and weeks and weeks. Weeks and weeks and weeks now to June. I think it started up around the middle of June. Yeah, right here. So we can see it where it really started up June 21st. Oh, guess what? We had V462 Lupi pop off on the 12th, and then we had V572 Velorum on the 25th. That's smack dab in between this earthquake swarm popping off. So that's kind of my point, is that it seems that we've had a big influx of energy from these two earthquakes, from these two nova explosions or supernova explosions. And then we've, of course, had a big influx of energy for the past 2-3 years or so due to solar maximum. And now we have this new coronal hole high-speed stream about to go geoeffective again as a new, even like third pulse of activity on top of these other larger waves. And we have areas that are already active right now on the Earth, and swarms often do precede higher magnitude earthquakes. But the other thing to keep in mind with swarms, very important, is that if you have a high magnitude earthquake, you get the fault rupture and you get that energy to ripple out like this. And usually there'll be aftershocks too, but it's kind of like a one event thing, like one big seismic wave just like this. An earthquake swarm is just continuously loading the nearby area and geology with energy. Yes, it's of a lower magnitude, but it's continuous. That's the thing. So if you have something that maybe resonates better with that continuous rumbling, that can trigger something versus, there's a lot of things in life that can take a big wave impact, right? I'm sure all of you probably know people that you have them, like there's a mountain that they need to climb in their life and they'll climb it. But if you were to like load like continuously more and more stress upon them for like 2 years, 3 years, they would break. So everyone has their own strengths and weaknesses. And this is just like a metaphor for the Earth, because there's, the universe and reality is fractal and self-similar and all this stuff. So there are certainly, I'd imagine, geologic features that resonate more with continuous energy input versus just one big like wave of input coming in. And so we see earthquakes are more common during full moons and new moons due to the tidal effect. It's about 0.5 to 1% of earthquakes seem to be triggered by that. Though if you look at high magnitude earthquakes, they are more likely during full moons or new moons. So that's one example of kind of this energy resonance effect. And if you have two earthquake swarms popping off, this one though being the dominant one, this one kind of starting up on the 9th and seemingly closing up, and that Mount Shinmoedake there popping off, clearly something's happening in that area. And there's this prophecy from a Japanese manga artist who's been right before on big significant events for there to be something to happen in July. And so it's all kind of lining up. There's been more than just that, though. We've also had an earthquake on the San Andreas Fault today in California. Not there right now. We'll be going back soon. Magnitude 4.3 just south of the Salton Sea, like right on basically the water there. So that's one of the biggest earthquakes that's been directly on the San Andreas in a while. We see the San Andreas with that red line right there. And we also had an earthquake at Yellowstone. So magnitude, what was it? Magnitude 2.7 right here in Yellowstone. So not the biggest earthquake, but for a volcanic system like that, it is larger. It's big enough to show up on the official USGS map. Typically, you're getting magnitude 1s or even negative magnitude earthquakes for these sort of systems like Rainier, Yellowstone, or other volcanoes. So magnitude 2.7 at Yellowstone as well. And let's not forget that we had a big earthquake swarm in Idaho just about a month ago. That was really popping off. I think the two are connected. But if we look specifically here at our largest earthquakes for the past day, we actually don't see any like magnitude 6s or 7s, right? That's not the most frequent. We do see this 5.1 there. That's even further south of that earthquake swarm there. So, I mean, magnitude 5 ring of fire is normal, but this swarm here is becoming anomalous, and they've started to evacuate some of the islands right in this area. So the Japanese are taking this very seriously because they have a long history with this, and they know what can happen after an earthquake swarm. You can get a big earthquake and big tsunami. You can get a big tsunami too if that happens. So they take it very seriously, whereas sometimes in the West, it seems that the scientists say, oh, earthquake swarm, don't worry guys, we don't want to affect tourism, so everything's fine. And one day that's going to not work out well for Western countries to not be actually respectful of the earth and her processes. It's just, that's my thought system and beliefs. Here we can see Lewotobi Laki-Laki, the volcano in Indonesia. This is the latest photo from there, and we'll see that it's still smoking. It's been having some big eruptions over the past couple weeks. I mean, going even further back than that, but it's significant eruptions over the past couple weeks. They've had to expand that safety radius around Lewotobi Laki-Laki. So that's another like hot spot of energy. And then of course we had Kilauea go very active recently. And here's the most recent episode of volcanic lava fountaining at Kilauea. So 1,000 feet plus, very significant. So there's been a lot that's been happening on the Earth volcanically in terms of earthquakes, and the astrological archetypal energies are really intense right now. So I think that's basically the update for you. Let me see if there's anything else that I've missed. I don't believe there is, but let me just confirm. Well, there's plenty of stuff that I have. Oh yeah, there are a couple things. There's plenty of stuff that I could continue talking about, but let me just show you the last one, okay? Then we'll do a question and answer. So here we have the Earth Analytics portal. This is provided by my website, earthevolution.com/energy-analytics. And here we have a bunch of data that you can look at all in one place on the Earth, the Sun, and even the solar system. We have our solar system scope online model embedded on this page. Really excellent resource for all of you guys. For example, we have these magnetograms that play. Sometimes these like don't work though. And it's just because of issues with the actual server that maintains them. So I don't know what the deal is. But in general, these are really great resources. For example, here we have our sun, our 171 angstrom view, and we can see the activity of the sun. And we notice a lot of new sunspot groups that are very active, rotating into view. And before it disappears, we have a very generous super thanks from Sally. Thank you so much for the super thanks. Incredibly generous. So blessings to you. And yeah, just thank you so much. Really appreciate that. That's awesome. So everyone in the live stream chat, make sure to say your thanks to Sally. So we see that there haven't been really any big solar flares, but we do have all these new active regions rotating in. And I haven't been showing too many views of the sun in this video because of all these flickering things that have been popping up over the past couple of days. I didn't want to trigger any people that are sensitive to this stuff. There's just been too much of these like flickering and data, you know, when they clean the cameras and stuff. It's just been too much. But we did have a plasma filament that blasted off. Let me show that. So we had two plasma filaments that have launched from fairly Earth center and direct. And the most recent one is going to launch from around here. So just give this a watch. It happened today. So we're about to hit today right now. Here it goes. There it is. So that occurred not that long ago. Give that a watch again. Right about here. Yeah. So that is still being modeled to see if that's going to hit the Earth or not. We've had some other plasma filaments launch off, but it has been a busy sun as it relates to plasma filament activity. But the biggest thing, as you can see, is our big coronal hole here that is going geoeffective at this moment in time. So that is quite significant. But again, these videos are just a little too crazy for me to want to show them. So here we have our radiation belts, and we see that we had a decrease in the flux right there, really went down. They're well charged before that. Here we see our time, it's July 8th now, July 9th, but watch how they recharge now after these hits. So they're starting to go up and recharge, and this is our higher flux colors right there. So now we're getting back to like reds and everything. Now we just dropped again to July. But our most recent radiation belt data is showing, again, I'll just go all the way to the end here, that our radiation belts have recharged to some degree. So they're also set and ready to enhance energy volatility a little bit on the planet if we get that high-speed stream impact to be significant enough. And here we have our global seismic activity level. So I want to show you this. This is provided by Volcano Discovery. And right now seismic activity is low. You'll see that, yes, we've been having these swarms and all the things, but in general, we actually haven't been having global seismic energy release to be all that high. If you take like the cumulative of all these different earthquakes, because we haven't had high magnitude earthquakes. That's where most of the energy release occurs. Every magnitude jump releases 32 times more energy. So yes, we've been having these swarms, unusual things, but in terms of just simply overall global seismic energy release, that's been bottled up. And you can almost see how it's been bottled up now, going back to not even just May, but in fact, going back to March with the magnitude 7.7. So imagine that 7.7 right here. And we've been on this like descending line like this, where we haven't had any earthquakes break through that. Okay, see what I'm talking about with this descending like earthquake activity? So we have this magnitude 7.7 there, a whole bunch of other earthquakes around it that were significant, magnitude 7, some 6.6s and 7s and 6.9s and stuff. This magnitude 7.4, Drake's Passage, and then look how we've just been going down since. So the earthquakes have been expressing themselves in different ways. That's a little unusual, but in terms of just global seismic energy release, it actually has been going down. And so I think that we're going to get something to break that trend fairly soon. That's why I think that there's something bigger coming. And the coronal hole high-speed streams, they can do that. So this one that we have coming up looks pretty significant. And yeah, at that point, we should be good to go. So let us do our question and answer. If you have any questions, then I will do my best to answer them. And just type @Stefan Burns in the chat so I can see your question. And any question that's attached to a super thanks will get priority. We will start with those. We actually have one right here from Anthony McNabb asking, could this be the reason Northern Australia is not getting a winter? It still feels like summer. Yeah, one of my friends in Australia was mentioning that it was like fairly nice weather, still going to the beach and everything. It's possible. Yeah, the nova explosions could explain that. Or at least they're not nothing. We know that energy came in from that. So it could definitely be one of the things, but we have good evidence linking these nova explosions. And again, the work, I first encountered this through my friend Max Raymond, and we're having a podcast where we talk about this coming out very, very soon. I just have to edit the video and post it. So just within a couple days, I'm hoping to have that video posted. But there are strong links between significant supernova explosions and then also climactic shifts that occurred right afterwards and then continuing afterwards that were they were distributed non-homogeneously, so basically in random spots, but not random. For example, the medieval warm period, a lot of that climbing, heating and just higher temperatures was specifically in the high Arctic, and those explosions that were kind of being registered around that time were way up there in the northern hemisphere, so basically hitting down on the planet. So you had Greenland very warm, Iceland very warm, Newfoundland, that sort of temperature variation, whereas other places were actually still cold and not the most habitable. So yeah, energy influx coming up to the southern hemisphere, and Australia has been still like in summer temperature, even though we've already passed winter solstice for you guys. It's kind of interesting. Thanks for sharing. And then we have another super thanks here that's coming from Nate, who also gifted 10 memberships. So thank you, Nate, for that. And he's asking, well, he's a software engineer, and he can help my site to not have service errors and to always have visible data, imagery, videos. Happy to help however I can. Yeah, please send me an email. Go to wildfreeorganic.com/contact and shoot me an email with your name, and we can talk about that, because I actually am in the middle of looking for someone who can help with the website. So that'd be fantastic. Really appreciate that. We'll go over to our live stream. We'll check back with the super thanks soon, but let's see what sort of questions have come in with the live stream. And here's one from Spicy Tuna asking, do volcanic eruptions affect the hurricanes in terms of intensity for Florida? If we zoom out beyond Florida, just in general, volcanic eruptions do change the atmosphere with their ash and gas composition. Hunga Tonga, Hunga Ha'apai in January 15th of 2022 released a bunch of water vapor into the stratosphere. So that is a significant climatic shift that occurred. That's the largest eruption of the 21st century thus far. Others release a lot more sulfur dioxide, which is a cooling factor because these sulfur dioxide crystals reflect sunlight. So there are a variety of things that volcanoes do to alter the climate. Now, how does that affect hurricanes? That's something I would need to research into. But if you get global cooling, hurricane intensity is probably going to go down. If you get global warming, like from water vapor and CO2, then it's going to go up. So that's just kind of the basic equation. But there's a lot of nuance to this. The more you research into this and the more researchers take observational data, take into account biology, the more you start to really understand that. So, and Lone Wolf is asking, can a G5 geomagnetic storm occur in a short period of time? We would need something that causes that. And we don't really have anything on the way that could cause a G5 storm. So I don't think we have any, when there's a G5 storm approaching, you'll know. We've had those approach on the channel. The subscriber number was a lot less, so there were less of you, but some of you would certainly remember those alerts that I put out saying, hey guys, big storm coming in. And actually a lot of the official agencies were saying, oh, just a G4, and then it actually comes in stronger than expected. So I'm pretty good at I'm not the best, I'm not perfect by any means, but I am pretty good at getting the forecasts pretty accurate in terms of accounting for these other energetic influences and taking that into my space weather forecasting, because other groups won't do that. They don't believe in some of these other things that I, just based on my experience, have seen to be true, or at least partially true. And Katrina's asking, do I have a plan, an Earthship? I would love an Earthship house. I don't have any of that yet. No, I'm just riding free and wild. So at some point I would like to have all that, but as of right now I don't. I don't think it's a bad idea, but I also don't think the world's going to end basically imminently. So Tony D is asking what the ozone layer looks like right now over the north and south poles. I do have that ozone data, so we can pull it up. Good question about that. And it just has to load. It's not really loading right now. And while we're waiting, Angela's saying the weather everywhere is actually way different. Most people don't pay attention. Yeah, I would agree with that. I think that the weather has changed quite a bit, and yeah, most people are just kind of lost in, I don't know, TikTok reels or something like that. So, or they're trying to stay alive, working 2 jobs and not making any money. So we got some serious societal problems at this moment in time. Here we have our ozone maps. But here we have our video for July for ozone. This is for Antarctica. So I'm not sure if that means anything to you, but I, for some reason, did not load the full 2025 video. Either way, we had some super thanks come in, so let me get to those. And the first one is from Masumura, who's asking, do you see Oahu, Hawaii going in or having a big earthquake and tsunami? No, you typically don't get big earthquakes on the Big Island or in general with Hawaii. You can get like up to a magnitude 5. I haven't seen anything more than that for Hawaii. But tsunami would be more the fact that there's an earthquake in Washington or Japan that sends a tsunami towards Hawaii. Or maybe you get a large volcanic slope to slide into the water. That could create a big tsunami wave locally in the Hawaiian Islands. But I don't foresee anything like that happening anytime soon. And then Robert is asking, is the SMOC ocean current reversal something that we should be worried about, and with other currents? So here we have a graphic depicting kind of what happens. You have Antarctica. You have these winds that blow off that push a whole bunch of fresh water over the surface. Okay, so that's low sailing. It's a low sailing environment. And what happens is you get that fresh water go out. It's easier to freeze, and so you get a lot of sea ice extent. And then when that melts, it creates more fresh water. So it keeps this freshwater system kind of alive. It's colder. Down below, you have saltier, warmer water. It's about 1 degree Celsius warmer. And so that's kind of trapped and insulated. And that has a lot of carbon and other nutrients with it. And then you also do have this zone where you have some of this water going straight down like that. It's really cold and dense. It's going straight down. What they've noticed is that in 2016 or so, there was a change in the salinity. So all of a sudden it went from there being more fresh water on top to there being more saline water on top. And so that's indicating that this push of water off the continent has gone down. As a result, these currents are going up more. So it's not like necessarily the entire current's reversed. It's a little bit of a simplification, but there are changes that have been occurring with the SMOC. And very likely, this is kind of a regular process going back and forth between saline and fresh water, and that there is this natural fluctuation between the two. These satellite observations don't go back that far. So that's the thing. We really don't know too much. But regardless, it is a change. And so that is going to affect the climate feasibly to some degree around the globe. And we are starting to see those changes, I feel like, right now, especially June, July, especially with all the flash flooding in the United States. Something weird is happening there. And by the way, they did cloud seeding in Texas like 24 hours, basically, before that massive flash flood that claimed hundreds. And it was upstream of the storm. So basically, the stuff was going right into that storm, and they're saying that didn't cause any effect. But I think it's really arrogant to say that, oh, we know 100% sure it didn't cause an effect. So yeah, these things are changing. They're always changing. It's good to be aware. It's good to be prepared. That's my philosophy. And we have another question that came in from Mildred. And she's asking about, I joined late, what's happening with the California warnings on a possible major earthquake imminent to hit? Well, if you must be new here, and I'm just joking with you, but there are always people saying that a major earthquake's about to hit California, and they've been wrong time and time again. Eventually, California will get hit with a major earthquake. That is not a, that's certainly going to happen, but as it relates to like tomorrow or the next week, we really just don't know. We just don't know. We've had this magnitude 4.3 here, or 4.3 just south of the Salton Sea on the San Andreas, but overall, like, it could happen 10 years from now. It could happen 30 years from now. We really don't know. Tomorrow, anyone telling you they know exactly when an earthquake is going to occur in a specific location and at a specific magnitude are probably full of it. There have been people that have gone right before, but it's very rare. It's very rare. You can count them basically on the number of fingers that you have on your hands. Maybe like you need 2 hands, maybe. So there are, and some people say that I do this, but I don't give specific locations or magnitudes or dates. I just talk about global earthquake trends. But there's always, if you point out a map for an hour and say this is going to go da da da, and you put out 100 predictions, some of them are going to happen. It's just kind of common sense. So yeah, I wouldn't be worried about it. Be prepared, but don't stress yourself out and worry about things that you have no control over. Do what you can to be prepared, and then live your life and have fun. That's my philosophy. And Randon Patterson is saying, just a comment, what you're seeing at the South Pole is a Birkeland current. If you look at the poles of Jupiter and Saturn, you see the same thing. Yeah, and we can talk about that more. I think you're the gentleman that we'll be meeting up with on Sunday, so that's cool. Thanks for jumping in the live stream, dude. Yeah, I'm not sure which graphic you're talking about, whether it's the ozone graphic or whether it is the climate analyzer graphic, which has these temperature anomalies. But we can go back here to really show that. But yeah, these electric currents of the solar system, they converge in the polar regions, both north and south, and they connect through the ionosphere. So the ionosphere has enough plasma and charge to help these Birkeland currents, which are field-aligned currents, so they follow the magnetic field out, right, to connect down, and then that's going to affect some of the, you would think, atmospheric systems that sit below the ionosphere. And they're also responsible for aurora and more. Ellie is asking, please explain the kill shot, then go underground. Yeah, I don't really... I think I know what you're talking about, but not in this video. It's not my type of vibe, not my channel. There's other people that spend every single video talking about that. But thank you for the super thanks, and for everyone else that has given a super thanks. Thank you so much for the memberships that have been gifted. All of you are amazing and wonderful people, and we are all blessed to be here together in this community of friends and Earth explorers. So yeah, please subscribe to the channel to stay up to date on what is happening with the Earth geologically, geophysically, solar activity, space weather, planetary resonances, cosmic forces. Today's video is a perfect example of how we bring all that together, the metaphysics and more. I've been your host, Stefan Burns. Thank you all so much. Smash that like button, help this channel grow. We are nearly at 350K. It's been insane. The growth on this channel has literally been bonkers. Trying to still understand it. Doing my best to just keep my head in the books, researching, looking at the data, giving you the best presentations possible. That is my pledge to you. That is what right now is in front of me with my sole purpose life mission. So happy to be here to support all of you with that. And I appreciate all the support that you send to me and all the love that you send to me as well. Sending love and light to you as well. Please take care of yourselves. I'll see you very soon.